Okay, hi everyone. We're going to work on some equations today. So we've done a little work, or you've done a little work in the past on some simple equations. We're going to try to take a look at a few more challenging equations today, ones that have more than one step. So let's get an example up here, and pardon my handwriting. So what if I have this equation right here? I have 2n plus 1 equals 7 over here. So the question then, of course, is what is n? That's what we're after. We're trying to solve this equation. So let me build a model of this, and probably should have used x, but I used n. I've got x's here instead of n's, so we're just going to have to pretend those are n's. So that's my 2n. So I've just represented the first term on the left side, 2n. I also have a 1 that I need to represent, and I'm going to do that by putting a 1 there. So I have 2n plus 1 on the left side. On the right side, I need 7. And everything is positive here, so I'm using my positive 1, 2, 3, 4, 5, 6, 7. I'm using my positive tiles. So, a couple of things that we need to remember here from our introduction into solving one-step equations. Number one, our goal is to isolate the variable. We want a statement at the end that looks like this: n on one side and equals something, the answer, on another. So in order to do that, we need to isolate the variable by getting rid of the addition of 1 here and the multiplication of 2. So that's our first goal. In order to eliminate some of these things, we use the same number but the opposite operation to get rid of it. Okay? So, and then whatever we do on one side of the variable, of the equation rather, like here on the left side, we need to do on the right. Okay? So let's keep that in mind. Unlike the one-step equations, here in the two-step equation, we have to decide, do I get rid of the 1 first or do I get rid of the 2? So we're going to work from the outside in. We're going to our goal is to isolate the variable right here. So we're going to go to the outside, what is furthest away from n, and that's the addition of 1. We're going to deal with that first, and then we'll get rid of the 2. Okay? So if I'm adding 1 here, I need to take 1 away. So in the next step of my solution, I'm going to say 2n plus 1 minus 1. I'm going to take the 1 away. And before I forget, I'm going to go over here to the other side, and I'm going to say 7 minus 1, okay? To show that what I did on the left side, I did on the right side. Now I need to simplify this in my next step here. So 2n plus 1 minus 1 sort of cancel each other out. The plus 1 and negative 1 make a 0 pair, so I can just cancel them out. Okay, and down here I'm going to have 2n, and it's going to equal 8. Okay, now the subtraction of 1 we can model two ways. We can either take away 1 like that. I've subtracted 1 from each side. Okay. I just realized I made a mistake here. I'm just going to fix that one. 7 minus 1 is 6. Sorry about that. Hope you guys caught that. So I could either take away the 1's, or what I could have done, because subtracting 1 or adding negative 1, I could have added negative 1 to each side, but it amounts to the same thing because the addition of negative 1 produces 0 pairs that are going to cause, and the 0 pairs will disappear, so I will still be left with 2n over here and 6 over here. Okay? Okay, so I've gotten rid of the addition of 1. Now I need to isolate the variable. Okay? So again, I'm going to use the same number, which is a 2, only I'm going to use the opposite operation, which is divide. Okay, so I'm dividing by 2 to neutralize the multiplication of 2. But what I do to one side, I do to the other side, and there I am. So to show the division of 2, I'm going to physically move my model so that I'm dividing it into two parts. And what I do to one side, I will do to the other to preserve equivalence. Okay, so now if we look down below here, I have a vision of what n equals. Right here it's telling me that n equals 1, 2, 3, 3. So I have a solution to my equation, okay? But I need to check it. So let's take a quick peek at how this all checks out, all right? So I'm just going to, no, I'm going to keep that there. But I'm going to move these up just to get them out of the way so I can write something down here. My original equation, as you recall, was this. 2n plus 1 equals 7, okay? I have an answer, and I think, I'm feeling pretty good about it. I'm feeling pretty good about n equals 3. So what I'm going to do to test it is I am going to substitute my n for the value that I think n has. And I'm going to see if I can solve it. Now, my right side is already simplified. It's already a 7. So I'm going to go ahead and simplify the other side here. So I've got 2 times 3, which is going to give me 6, but I still have plus 1. And in my next step, I see 6 plus 1 equals 7. So I have 7 on my left side. I have 7 on my right side. So that tells me that my answer is correct and that n indeed is 3.